Hello, this is Balaji Ganesan from IBM Research. Today, I'll be presenting Anu question answering system. This is a question answering system for answering questions on COVID 19 built on top of several semantic technologies. I'll be describing five technologies in particular. Then I will go over a demo, and finally, we will have time for questions. The first semantic technology that I want to describe is data augmentation. So our question answering system is built on top of a knowledge graph. This knowledge graph has been built specifically for COVID-19 with the concepts, relationships, and attributes that are relevant from our point of view. So we have used several neural models in order to extract entities and relationships. However, one particular system that we found to have been very helpful is data augmentation using a rule-based system called System T. So, using a series of simple rules, a subject-object predicate pattern, or a dictionary of nouns, or a dictionary of terms relevant to this particular domain, we are able to extract uh, several relationships and attributes which would otherwise not be possible using the neural models. And our work shows that this augmentation helps to make the knowledge graph more complete and also diverse in terms of content. So that's the first work that has gone into the system. The second one is based on temporal point processes. When we built this particular knowledge graph, we looked at several unstructured data sources, in particular tweets that are related to COVID-19. So this particular data set from QCRI includes tweets from the early 2020 on COVID-19. So typically when there is a time associated with the data, either in terms of the time at which it was tweeted or the time at which a particular unstructured data was updated, that particular timestamp can be used to improve the clustering and also to identify entities which would otherwise remain as two different nodes in the graph. So this work we call as entity re-resolution because we start with an initial graph and then update the entities of this graph as we get more updates from either social media or from updates to unstructured data. So this is the second technology. When we have multiple data sources, there is a need to bring these labels together. So for this, we have used what is called as a unified hierarchical label set. We present an algorithm that uses the same attributes or descriptions that are present in multiple ontologies or label sets in order to bring them together into a single hierarchy. If you build such a unified hierarchy, then we observe that downstream systems can work with a single ontology and the completeness of the schema remains as good as having multiple ontologies. So this particular work, which was published early last year, has been used in this COVID-19 application and it has been found to be useful. Then I want to describe about explainability. So given this is a question answering system on COVID-19, and we have built a COVID-19 knowledge graph to go with the question answering system, we wanted to be sure that the links that we are predicting using graph neural models are understandable to end users of this system. While there are several interpretability solutions based on post-hoc models or self-explainable AI, in this particular work, we show a system which draws upon fact verification. So, in order to explain a link between two entities, we feel extracting a passage or a log entry containing these entities is much more valuable to the end user, along with any other explainability that we can get from models like Lime or anchors. That's the explainable link prediction portion. Finally, the end users of a system like Anu might want to pose questions in natural language rather than write SQL queries or Sparkle queries. And also, they might prefer to ask natural language questions instead of just inputting some keywords that we are familiar with from search engines. So that's where this natural language query system that has been built and published as Athena has been integrated into our application. So whether the data is in unstructured format or is it in graphs or in structured data, we can query the system using a single ontology that we described earlier. Now we will go on to the demo. So as I briefly mentioned earlier, so this is joint work between IBM Research, a student from IIT Kharagpur, and IBM Data and AI. Let me begin by asking a simple question. We have in fact collected a series of questions that are frequently asked. So let me use one of these questions. This one, like, what are the symptoms of COVID-19 seems interesting. Okay, so as you can see at the top, some of these answers could come from unstructured data. In this case, this particular answer comes from a FAQ series of frequently asked questions that have been put out by a government entity. So in that sense, this could be a more authentic answer. Then we have extracted several answers from the social media, in this particular case, Twitter. As you can see here, we have a number of tweets, and there is a score associated which comes from the search index. However, this particular ordering of these tweets is influenced both by the content as well as the time associated with it. That's where the temporal point process, in particular Dirichlet-Hawkes process, comes into the picture. As you can see, we have extracted several entities from each of these tweets. For example, here coronavirus and symptom from this particular tweet. So any entity that we cannot automatically extract using neural models, we use the data augmentation technique that I described earlier. So having found these entities, the DHP gives us clusters. As you can see here, all the tweets in this particular answer belong to a single cluster. So here I have the different entities that have been extracted from the tweets corpus. So if I choose, say, coronavirus, that seems to be a glue entity. Several other entities are related to coronavirus. In particular, like, we are interested at like the symptoms for coronavirus. So in this case, if I choose coronavirus and fever, we see that they are indeed linked, and the link type for this particular relation is symptoms, and this happens to be coming from the ground truth, which is extracted using system T. But these kind of relationships can also come from the graph neural model. As I explained, there is a reason. In order to, there is a reason why these two entities have been linked in this particular graph, and it would be nice to explain this to the users. So the way we do this is by extracting a sentence where these two entities occur together. So this particular tweet that we saw in the search results gives more confidence to the user who's exploring the knowledge graph to understand why these two entities might be linked together. And we also see in this particular graph that there is also a system first class entity, and it's related to coronavirus, a fever, and several other symptoms of coronavirus. That's pretty much what I have for today's presentation. Now we have time for questions.